Okay, tak apa Adi. Saya ingat hari ni tak apa. Tapi next time tolong remind because this is for whole class. In case Adi forget, all of you can remind me as well, okay? Don't worry, okay? Don't put the responsibility 100% on Adi, okay? Because this is all for you. If I forget, then finish our class, okay? Because I cannot record back again. Okay, so before I start the class, okay, okay, before I start the class, where is the pen? Okay, so let's say we have okay, so if let's say we have x, okay, x equals to y equals to x t plus 2, okay, t plus 2. So is this an advance or is this a delayed signals? Okay, is it a future, for example, advance like future, or is it delayed? So if we have like this, what I teach you guys, right? I teach, remember, just to spread directly, separate it. Okay, so this one is actually negative, then you have negative here. Oops, negative here. Okay, in the timeline it will be, okay, in the timeline, let's say your signal here, okay, let's say, okay, I can just pick in the whole type of signal. Let's say this one is 0, timeline 0, and then this one negative 2 means it is going backward. Okay, so it is advanced. So instead it will happen much faster, okay, which is before, so it is advanced. So it will be negative 2 here. Okay, your signal will be here, your new signal. Okay, okay, do you guys understand? I just want to refresh that. Okay, you guys understand? Okay, okay, thank you. I see the Google chat. Okay, so now we go to this section. Okay, so today we will start with introduction to signal and system part 2. I intend only to cover until sync function. Okay, I intend to cover only this. Then the rest of this will be in the recorded live lecture. Okay, and I have some question here. Okay, but not sure we able to cover or not. Okay, you guys can, maybe I will give as a homework. Okay, and you guys can submit in forum later on. Okay, just for you. Okay, if you didn't do, you have, I mean, you forum, of course I ask you guys to submit, but of course I cannot check everyone every time, but this is for you, for your benefit. Okay, for your exercise. If you didn't do, then you'll be in problem facing quiz, even let alone test and signals, test and final. Okay, so we go to chapter 1, introduction to signal and system part 2. Okay, so the outline will be, last time we already covered the introduction, type of signal and signal operations. Okay, you study all types of operations. Okay, today we will cover on the basic function. Okay, on the basic function. Um, what is basic function? It is the elementary. So means that you guys need to know this minimum. You need to know these minimum functions, because this function will be used often in order to solve multiple types of combined function later on. Okay, combined function later on. And then also one of the important thing that you guys have to remind me. I understand because this is online class. My internet sometimes problem, or if my internet problem, I can repeat, no problem. But if your internet not that stable, you are sometimes left, I mean, you suddenly left the lecture. By having record, you can watch again if you have some, if you cannot attend the whole session because of internet connection. Okay, so please remind me. Okay, this is for you guys. Okay, so then the basic function, we have a sinusoid and complex exponent. Okay, unit step function, ramp function, impulse function, rectangular, triangular, and sync function. I try to cover until sync function if we have enough time. Okay, so this is sinusoids and complex exponential signals. Okay, I don't know if I can divide the screen with the pen. Okay, it will be too small like this. Never mind. Okay, I speak first, later I to explain. Okay, so we have continuous time. This one is a continuous time sinusoid function. Why we call it sinusoids? Because sinusoidal. So you have either cos or you have either sine. Okay, if you have tangent, is it sinusoid? If you have tangent, is it sinusoid? Is it sinusoid or not? You guys can respond in the chat. Okay, if you guys have sinusoidal, if it's one example is cos and sin. But if you have tangent, is it sinusoid function? If you have a tangent 2 pi over t naught plus theta, is it sinusoid or not? Can you guys answer? So it is not sinusoids, okay? Sinusoid is sinusoidal shape, okay? Okay, good. So here we have a cos 2 pi t naught plus theta, okay? So, okay, let me, okay, just here, okay. Okay. So you have this basic function that you guys should know, okay? And basic equation 2 pi f, okay? 2 pi f. And at the same time, you know f is actually 1 over period, okay? 1 over what? Complete period. T is complete period. Okay? So sinusoid function, okay, for example, you have a cos 2 pi t naught plus some shift, okay? Maybe some shift here, okay? So you need to able to change this if the situations need. So here, if you can see, this is actually 2 pi times 1 over t, okay? So it is actually a cos 2 pi f plus theta, okay? And we know that 2 pi f is actually equals to omega. So you can do the replace, okay? So make sure you guys know this, okay? I don't teach this for nothing because sometimes later on question will be more difficult, okay? So omega plus theta, okay? And then we have, and then a cos 2 pi f naught t, a cos, you see here, okay? And this is the equivalent of the exponent function, okay? Exponent function. Maybe a bit small, but later on I will share the slide, okay? So you see the conversion, okay? You see the conversion. So A here is the real amplitude of sinusoids, okay? I think you guys know the amplitude, right? If we have a graph, okay? So let's say this is 3, let's say this is -3. So the amplitude is what? The amplitude is 3, okay? And then we have a real fundamental period of sinusoid, which measured in seconds. Fundamental frequency measured in hertz. Omega naught is radian per second. Continuous time second. And this is the real damping rate, okay? Real damping rate, maybe it will mention in the question what is the damping rate, okay? So other than that, J omega naught T is not that you need to able to relate this question, okay? Sometimes you need to change from here to here, from okay, or from here to here, okay. You guys can see here is cos omega naught. When you want to solve for exponent function, okay, if you want to see the equivalent, this one, okay. See here, j sine omega naught t, okay. This is the imaginary part, okay. So now we have, now we go to this sinusoid and complex exponent, okay. How should I start teach this one? Okay, never mind. So where is this? Okay, so first apa tadi kecil sangat, negative 4 sine, wait too small, 200 pi t. So 200 pi t, okay, microampere, okay. This microampere, just forget it, okay. We anggap je ampere, okay, because oh my god. Okay, so this is 4 sine. Okay, first we need to know the sine function. Okay, we need to know the sine function. The sine function, is it this one or is it this one? A or B? Which one is the sine function? Okay, thank you. It's A. Okay, it's A. So first you need to know. Okay, so B is what function? Okay, yes, B is cos. Okay, so B is cos. Okay, first of all, although his question look like silly, okay, but it's the basic. Okay, then the question, this is A sine, so then the question now is 4. We have 4 sine. Okay, let's say we have 4 sine. So you have negative there. So when we have negative 4 here, what amplitude based operation we have here? How many operation, and what is the operation we have? Negative 4. Negative 4 sine. So what is this? Amplitude what? Is it amplitude shifting, amplitude scaling, or amplitude inversion? Negative 4 sine, this one. Yes, okay, thank you everyone for answering. This is actually amplitude. First, you have amplitude inversion, this one, this guy. Then the next is amplitude scaling. So first, you have scaling. So now you have here is 4, okay, scaling, 4. Okay, and this is negative 4, okay. Scaling, and then inversion. So you have inversion, so instead you will look like this. Okay, sorry if my, oh my god. Okay, so it will be 4 and negative 4. Okay, then this we finish. Okay, make sure you, when you draw the scenario, make sure it looks repeated. When you answering question later on, don't only answer when you give answer to me in test later on, don't only like this. If it's repeated, make it a bit look like repeated, like here. Okay, like this. Okay, understand? Don't only look like this. This one doesn't show it is repeated harmonics. Okay, it should show some repetition like this. You see? Okay, I have more than one complete signal. Okay, and I'm not sure what you guys the other sections. I'm not sure the other sections why students are going to my section and leaving the other section. I'm not sure why. But if students' concern is the lecture might be strict in marking, okay, I just want to let you guys know. If you guys think that you may leave the section because the lecture strict in marking, maybe, I'm not sure. it's no point because this final for signal, we will do T marking. I'm not sure you guys understand the word T marking. So we'll do T marking means maybe I will mark question 4, the other lecture will mark question 5. So I will not totally mark all of my students' answer for final. Okay. So if students are running away from the other section, going to my section, just worry of the strict marking, no point because all lecturers will mark all this, will do T marking. Okay. Means I will not only mark my section 3 and section 4, but I will mark other section like section 1, section 2, but maybe only question 1A, for example. Question 1B will be marked by other lecturer. Okay. So I think it will be fair. Okay. And you see here, this is the exponent. Okay, this is exponent. So I think this one you learn from your school. I hope. Okay, I hope you learn from your school. Okay, first you have exponent, exponents, and then what here? So you have two. Okay, am I doing? Wait. So you have this one. Okay, you have these two signal. Which one is actually okay? Okay, never mind. Let me start first. Let's say we have two something in the beginning. Okay, then we have if it's 2 here means it will need to pass the value of 2. Okay. Now my question is, which one is actually representing negative 10t? Is it this one or this one? Is it A or B? You see there is two shape here. Which one is the correct representation of 2 exponent negative 10t? Is it graph A or graph B? Okay. You guys can see here. So what is your answer? What is your answer? Is it A or B? Which is the correct representations of exponent graph? Okay. Okay. So you guys can see the majority of the answer. But you know, majority doesn't mean they are correct. But I didn't say B is wrong, okay? But please do homework, okay? Search for this, okay? Search for this. What is the... First, you need to know in your secondary school, you already learned exponent graph. But now you have this kind of exponent with negative here. So your exponent will look like A or will look like B, okay? Homework, your own homework, okay? So this one is cos, okay? Cos graph. This one is, you see here, this one we have damping, okay? Where is the question just now? Okay, so you see here, we have here is real damping rate, okay? We have real damping rate. So you see here, there is damping, okay? Damping here, you see here is, let's say, this one is sigma. I'm not sure if you guys can see it clearly. I'm sorry, okay? Is it clear or not? Okay. So you see here, there is sigma here. This sigma is actually real damping rate, okay? So you see this equation, then we try to compare to the other graph, okay? You see here is 5 ET sine omega, sine 2 pi t, okay? So if you see here, there is a damping rate, okay? There is a damping rate here. And you can see it is damping. Damping means it is decaying. Means sooner or later, the end is what is? What is the amplitude? You guys, if you guys can answer me, This one is damping. In the end, what is the amplitude? In the end. Yes, correct. In the end is 0. Okay. So this one damping. Okay, damping is actually practical in life. Okay, let me show. Okay, let me show for the field of communication. Okay, I am communication engineering. My field is communication. Let's say don't save. Okay, let's say you have signals. Okay, let's say you have a base station. Okay, you have signals. Okay, you have signals. Then over very long communication signals. Okay, so you have like this. Okay, so the signal this one is of course electromagnetic signal is like this. Okay, if you take EMT later on, you know. Okay, but I just want to make it for easy drawing. Okay, you just see from one side view. So in the end it will reach until 0. Okay, let's say ini rumah Hanisa. Okay, let's say this is the house, Hanisa's house. Okay, and then let's say this one is let me see the names. Okay, I try to remember your guys' name, that's why I pick. Okay, this one, let's say this one is rumah Farah. Let's say this one is the house of Farah Akila. So Farah Akila, at this maybe television, for example. Okay, Hanisa can get a very good connection. She can watch television, but maybe Farah here is screaming, no channel, something like that. And then maybe, for example, Intan here, she will get a very good quality of receive signals. Okay, so something like that. Okay, but ideal, okay, ideal, which is not the real world. Ideal is, we assume is actually no damping, but this is not really the real value. This one is the real. Okay, so what else just now? Okay, okay, this is a unit step function. Okay, unit step function, what is the meaning of the unit step? So unit step means a unit step. Okay, means it's just a unit and it's a step. So you guys can see it's employed to switch the signal on and off. So definition, you have U tau. So the magnitude. Okay, this is the original signal. You need to remember. It's better to remember, but I think in the final they give question. They give some tables. Okay. Wait for a while. Do I have the spatial signal? Oh, I don't have. Later on. Okay, later on. I don't have that. Okay, so you see, for time greater than 0, you have the magnitude of 1. Other than that is 0. Okay, here time tau is independent variable, is a linear function of time. So this is what happened to this signal. What happened to this signal, this example signal? Is it time shift, time scaling, or time inversion, these signals? What is your answer? Is it time scaling, time shifting, or time inversion? Just now, the example here. Yes, correct. It is time shifting. Okay, the original, okay, thank you, is a time shifting. So the original answer, the original unit step function is like this. Okay, we start from 0. Okay, like this. This is the unit step function. So you have here is the value of 1. Okay, so this one is your unit step function, ut. Okay, Of course, if you have ut, let's say you have t plus 1, okay, and then you separate like I told you. But if you don't separate, it's okay, but you need to know it's separate, right? Inside your brain, you separate it, okay? Negative 1. So your ut will be here, okay? You'll be advanced by 1 second, okay? Here. Now the next is we go to next examples, okay? What is this? Okay, plot the function given by. Okay, so we go for, not sure if I can finish it. It's already 9. Okay, but inshallah, okay, I try my best. But if you guys don't understand, please ask me, okay? Otherwise, I will assume students understand, okay? Just interrupt me, but unmute your microphone, okay? Uh, so you have x, t. Wait for a while. I'm changing screen. Okay, I'm changing screen because it's difficult. Okay, because my laptop is touch screen. I think it will be faster if I using touch. Okay. So wait for a while. Okay. Okay. Is it clear? Is it clear to you guys? So I hope it's clear. Okay. So now is okay. Wait for a while. I'm adjusting. Okay. So we have xt equals to what is just now? 3 ut plus 3, and then we have what? We have minus ut plus 3 ut minus 3. Ay, my God, panjangnya soalan ni. Ut minus 6. Okay. Okay, let's wait. I want to see if I do it correct. I type it correct. 3 ut plus 3 minus ut plus 3t minus 3 ut minus 6. Okay, I think it's okay. So you have actually you have how many you have individually you have 4 graph. Okay, you have graph A, graph B, graph C, and graph D. Okay, you have 4 graph that will be combined. Okay, that will be combined. So let we see first for graph A. Okay, I make this a bit small. Okay, I hope still clear because I need more space. Okay, let's say we want to draw graph A now. Okay, graph A. So you see here, this is actually okay, there is time shift. So you settle, you solve the inside first, right? Am I correct? You solve inside first. So here, I just want to show first 3 ut separate. Okay, separate. Okay, I just want so that you guys know what is actually happened. My method is a bit slow, but if you understand, it's good. If you understand and you don't have to follow me, okay, you guys can just straight start. I want to help those that have a bit slow in understanding. Okay, so okay, you have minus minus, and you have the rest. Okay, wait, Wait, never mind. I just until finish. Okay. U T plus 3U T minus, okay, you see I try to distinguish them, okay, but if you later on expert already, it's okay, okay, you just don't do like, you can do skip this step, okay. So we want to do the graph A first, okay. First, you see graph A, there is a time shifting, okay, inside time shifting. Then you do some amplification here, okay. So you see the graph A first, okay. The graph A, first of course, like I told you guys in the recording lecture, remember to do this correctly, okay. This one is your T. Let's say this one is x1t, okay. They say, okay, x1t, okay. Use please use a bracket, okay. So shifted by -3, so it should be here, okay. And then it mentioned that it is a time scaling by 3. So what does it happen? What does it mean? Time scaling by 3? Sorry, it's not time scale, it's amplitude, okay. So first it's shifted by -3 here, -3, and then it is amplitude scaling now. So it is 3. So this is your graph A, okay. Now we go to see your graph B, okay. Graph B, okay. So graph B is not tricky. You need to be very careful in doing this question, because you might miss, okay. You might forget this one, okay. I'm not sure how you're going to remember, but you might forget this one, negative, okay. You might forget the negative. So I'm not sure how you're going to do, but you guys can whether you guys can minus here, minus, or you guys can just put the you guys include already the negative unit step. So if you include directly, you will have a graph, okay. Okay, now you have negative ut, means your graph is terbalik, okay. This one is amplitude, what, amplitude shifting or amplitude scaling or amplitude inversion, this graph B. Is it amplitude shifting, scaling, or inversion? Okay, so it is inversion. So you have your graph here, but no time shifting, okay? No time shifting, so it is here, -1, okay? -1. Actually, the graph look like this, okay? Put the red color, okay? So this one is like this, okay? Okay, then graph C, okay, graph C. What is graph C here? Okay, graph C is delayed. Okay, delayed by 3. So you should start by 3, and then it is, you have amplitude scaling. Okay, amplitude scaling. So you have so your graph should start here. Okay, shifted by 3, and at the same time it is scaled to 3. Okay, so this one. This is your graph C, and then graph D. Oh my God, this question so long. Because for me, as long as student understand, maybe 3 signal is enough. I don't know why until 4 here. Okay, in UT minus 6, okay, graph D. Now we solve for graph D. Okay, graph D. So here, if you see, if you see here, minus 6. Okay, minus and positive 6. So it is delayed by 6. So you have another here. Okay. But what is the magnitude here? Is it 1 or 3? Is it 1 or 3, this magnitude? Is it 1 or 3 for graph D? What is the magnitude here? Is it 1 or 3 for graph D? Is it 1 or 3? Okay. So it's 1. Okay, good. Okay. Thank you. Very good, you guys. Okay, then for this one, you need to add all of this, okay? Because I have no space, I have to okay. Let's see if I think the lecture already have just now this. I don't need to. Okay, the lecture already have, but I record. Okay, so I mean the lecture already show the final solution. It's okay. So I can just okay I did so new. So if you add up later on all of this guy, okay, when you add up all them together, okay, you will have logically you will later have the same graph, okay, the same graph just as in the solutions, okay. You will have that. You please try at your own, okay, please try at your own later on, okay. Eventually you should have this graph, okay. But make sure of the time, okay, means you will have what is the time. You have the time example -3, 0, 3 and 6, okay. You have that just now, okay. Because just now when we do our operations, okay, we have time delay by -3 and then we have time at 0. I'm not sure just now. Saya dah lupa dah apa saya lukis tadi. Okay, you have 3 and you have 6 and then you have what else? And then you have 0, okay? Then you have 0. So make sure you have this. And then later on, you need to add up the signals, okay? Within the range like T less than 83, what happened? T after 0, then T after 3, then T after 6, okay? What happened? But actually from the graph, I think you guys can understand, okay? Make sure you graph your individual graph is correct first. Only then you can do this one. It's quite direct, okay? Quite direct. No magic there, okay? So try first later on, okay? Try, then we see if you can have problem. You guys can contact me, okay? Or if you notice, I will create my lecture note inside a forum, okay. Why I do like that? Because do you guys already download my lecture note or not, the previous lecture? I'm not sure if you guys already download my previous lecture. If you already download, please respond yes, okay. If not, maybe you're not sure where to look at my lecture, okay. So I put inside forum. Maybe some lecture put at file. Last semester I also put at file. Now I put my lecture note inside forum. Why? Let's say Zelafi tak faham. Let's say Zelafi don't understand some content inside that lecture slide. She can post the question in that forum of that lecture's note. Okay. And then other friend can, if your friend are right hardworking, she can see Zalafi, I mean something that she don't understand. Maybe the other student also don't understand, but they don't know what they don't know. So at least when Zalafi asks in that forum, and others can see. Okay, this is all. If you record everything, it's easy for you to revise. Okay, maybe for your final later on. Okay, so please use the forum. Okay, please use the forum. I don't force you to respond there, but please use that forum if you have something to not understand. Okay, and of course, when student responding to the forum, I lecturer get some response if I know mistaken. So I know if you asking question. Okay, so we go next for the RAM function. Okay, we go for RAM function. RAM function is the function that changes linearly before or after some times. Okay, so you have to distinguish there. After some determined time and after some before determined time and after determined time, there is a changes. Okay, or is multiplied by function that changes linearly before or after times. Okay. Apa yang ni kecil sangat sekejap. Okay. is obtained by integrating the unit step function. So how you actually obtain this ramp function is that you integrate the unit step function. Unit step function is the U just now, okay? You integrate by, you see the integration from 0 until t, unit step and time and delay. I think this one is advanced, okay? Advanced, is it advanced? Oh no, this is delayed. Okay, delay. Okay, negative minus t naught and d tau. Okay, d tau, and then ft. Then you have t minus t naught u t minus t naught. You see, this one is a unit step function. Okay, this one is a unit step function, and this one is the what? This one is signal multiplication. Okay, signal multiplication. So you have this one minus with this one. Okay, multiply with this one. Okay, I exit this full screen first. Okay, where was I? Okay, so RAM. Okay, this is the RAM function. Sorry for the sound. Okay, my room is just near the kitchen, so sometimes you will listen some noise. People washing hands or kitchen. Okay, any sounds that you're familiar with comes from kitchen, you will from my lecture later on. Okay, so this is the RAM function. So this is the RAM function. This is the standard one. Okay, this is standard RAM function. So you need to describe like RAM. Okay, RAM function t. Okay, this is the standard. Then you have whatever time shifting, whatever. Okay, for example, let's say if you have some time shifting, you have a RAM. This one you put here. Okay, you write here on top. Okay, let's say later on if you write, if for me, if I'm marking your paper, if you don't write this properly, I will cut marks. Okay, I will cut marks for sure. Okay, I don't know other lecturers, but for me, I will cut marks. Okay, so here I don't have space. That's why I write here. So RAM, let's say we want RAM t plus t naught. Okay, t plus t naught. So if t plus t naught, is it time advance or time delay? This one, is it time advance or time delay? Is it time advance or is it time delay? Okay, correct. So it is a time advance, so it will be advanced here, t naught. Okay, so you will have your RAM. Because this is actually negative t naught. Okay, advance. Okay, so I think this one is quite understand the function, the one that they shown here. Okay, thank you for the response. Okay, I can see you guys respond. And this is recorded. Okay, later on, let's say I think we can see Nurul Aina is responding. We can see Hanisa, Shafwendra, okay, Afia. Okay, you guys can see on your interaction to my lectures. Okay, so example here, this. Okay, so I think this very this one is self-explanatory. Okay, so RAM t minus t naught. Okay, the answer t for t greater than t naught. Okay, I'm not sure why it's like this. I think there is mistake. This one should be 1. Okay, this one should be 1. T greater than t naught. T greater than t naught. What is this? Wait for what? RAM t 0. Oh, okay, I understand. Okay. For t greater less than 0, it will be 0. Okay. For here, it will be the t value, okay? Asalnya kan macam ni, sekejap The original just now, the original, okay, original signal, I'm talking about the original. If this is 1, here is 1, okay? If this is 2, here is 2. This is original, not you have any amplitude scaling or whatsoever. So this is 2. So if this here is 3, here is 3, okay? Okay. So this is the example. This one is representation of these examples, okay? So far so good? So far so good? Ada question tak? Do you have question? If no question, I will proceed, okay? Okay. So this one is impulse function. Impulse function. I'm not sure if you guys okay, if you learn physics, okay, I think you learn physics. If not, you're not going to continue engineering here, okay? So I think you learn physics. Forget wait for a while. Physics. Okay, this is not really related, but I just want to see. So this one is impulsive force. Am I correct? This one is impulsive force. When we talk about impulsive force, is this force happen during a short time or long time period? A very short time period or long time period? Is it very short period or long time period? Okay, so it is very short. So this is impulsive force. So from the word impulse, okay, from the word impulse, I don't want to okay lah, tak apalah, saya rajin sikit. Okay, impulse, from the word impulse, okay, then you can relate here, okay. So it is very thin. Impulse function is very thin. That's why we call here impulse, okay, impulse. So it has 0 value at all time except at t0. The area under the unit impulse function is 1. The area 1, very thin, okay. Dia punya tebal tu, the width only 1. So macam 0.5 lah, lebih kurang macam tu. And then define by, so this is your impulse, okay. This is your impulse functions, okay. Let me go so impulse function is very thin. Okay, so the logo, the symbol you can write like this, okay, impulse. Okay, impulse. And then if you have some delay, you can tambah t minus t naught, depends, okay. But the originals, okay, the impulse, the original, I'm not talking about the things with modification here, okay. This is your impulse function, okay. Impulse function, omega impulse, okay. Then of course you can have some delays. If you have some delay, for example, okay, if you have some delay, or if you have some advance also, okay. If you have some advance, let's say t plus 3, okay. So what happened is that this is your 0, your impulse function is here, okay, negative 3, okay. Then that is it, okay. Then what else the question, the lecture says, okay, can be estimated by one narrow impulse rectangular with one unit area where the width of the impulse has a small value approaching to 0, okay. This one, this symbol is approaching to 0, means, you know, it's very narrow, okay. It's very narrow, that's why this one is approaching to 0, okay, approaching to 0, maybe 0.000, something like that, okay, because this is very thin, okay. So this is your impulse. So you have learned just now. So you have learned up until now. You learn about unit step function. You learn about ramp function. Then you learn about the impulse functions. Okay. Next, what is this? Apa ni? Oh, okay. So you have properties. I think this Shafwendra, I'm not sure this. I think this one is given in the past. This one is given in the final exam. Okay, I think. I'm not sure. Later on, I don't have the final set with me yet. It's not that I don't have. I don't download it yet. Okay, I will lecture for us lecturer. If I know second, I have the collection, but I not yet go to the collection. Okay, so you see, this is all the properties of unit impulse function there is. Okay, so you can see here, right? Okay, if you don't understand any of this, yeah, you can ask me later on. Okay, but this is basically the unit impulse function. Okay, you see, like number 4 here, number 4. Okay, unit impulse function is you obtain, okay, unit impulse function with time delay is actually the differentiation, okay, with respect to time for the unit step function. So, okay, and then we have you have unit step function here, t minus t naught. Then is actually the integration from negative infinity, okay, negative infinity until t for the impulse, okay, for the impulse t minus t naught, okay, and so on. Uh, I don't think you logically you guys don't have to memorize. Okay, maybe you guys need to know how to use, but I'm not sure. Later on, I will see the final year. Okay, I will see the final year later on. Okay, to see what kind of question you make it. Okay, so we go to the next one. In fact, we are almost finished. Okay, we go for the rectangular function. Okay, has a unit value for its width. Okay, you see the word here has a unit value. What does it mean by a unit value of width? What is the width then? Is it mentioned a unit value? This is, I don't if a unit, so what is the width for the rectangular function? What is the unit? I mean, how many? Is it 1 unit, 2 unit, 3 unit? What is the unit for the rectangular function? Okay, you guys can answer at Google Chat. Okay, what is the unit? What is the width of a rectangular function without any modification, the original? From the word here, you can see it's a, so it's 1 unit. Okay, it's 1 unit. So that's why you have here, this is the original rectangular function. So you have negative half, then you have half, then you have magnitude of 1. So rectangular, a bit lari sini tak apa. Rectangular 0, okay, other range of t, it is 0, but for within the regions negative half until half of that t, you have amplitude of 1. Okay, so this is and then operate as an off switching function in a certain signal after 1 period. So I'm not sure, I really not sure if you guys have studied it or not. Okay, if you want to turn on something, okay, if you want to turn on something, I'm not sure if you want, okay, let's say this, imagine the timeline, okay, the timeline. Okay, if you want to turn on some things, okay, if you want to turn on something, means not all the time it will turn on, right? So let's say here, so your rectangular function is here. So this is rectangular t minus t naught, okay. Okay, so this not all the time will turn on, right? Macam you, like you want to switch on your fan, not all the time you want to switch it on. Okay, so this is, so that's why this is switching on at that time, but the other time is like switching off. Okay, timeline, this one timeline. Contoh di sini mungkin fan on, contoh fan off, Contoh this is just analogy, okay, to make you understand, okay. Then this is the way you write, you should write like this, okay, recti, okay. Of course the original is here with half and one, and then the way to write is rectangular t, okay. What else? Just now I think I forget. Okay, so just now I think I forget to show you guys um, how we actually get our rem function. Okay, you see just now is the rem, right? Rem like this. Okay, this is the rem. Okay, this is the rem function. But how we get this function is actually rem is actually you get it by t times by unit function of t, a unit step of t. So first you have the graph t. Okay, you have the graph t like this. Okay, you have graph t just like y equals to mx plus c. Okay, y like mx plus c, but here this is your t. Okay, so that's why this one is, let's say, your x. Okay, your, sorry, say this one is your y. Okay, your y. So y mx plus c. So y equals to keturunan satu, and then you have t, and c is no y intersection, is 0, right? So that's why you have y t. So this is t, okay, t function, maybe y1 t whatsoever. Okay, as long as you guys understand. Okay, I may have used different label. The important thing is to understand. Okay, then I said this multiply by 0 unit step function, right? So you multiply by unit step function. Unit step function is on all the value here is 1, the rest is 0. Okay, the rest is 0. That's why this one multiply by this one, you will see all of things that before, let's say origin, before 0 is 0. So that's why this one get cancel. Okay, this one get cancel. Then you only left this function. Okay, then you only left this function. Okay, because everything times like this one, everything times by 1 will get the same value back. So that's why you have this. So that's why rem t is equal to t times unit function of t. Okay, like this, multiply. Understand or not? Yes or not? Please mention yes if you understand. Okay, I hope you guys understand. Do you guys understand? I don't like, if not, I will pick names, okay? Do you guys understand or not? You have to mention yes there at Google Chat if you understand. Understand or not? No response? Huh? No? No understand, huh? Okay. Okay, don't worry. Good. Not understand. I mean, not good that you not understand. Means that you are listening to my lecture. Okay. So Remti, wait, Remti is actually a resultant of t times, okay, times unit step function of t. Okay, this is your Remti. Okay. How about the others? Only Nurul, Aina, and one Siti Hadijah don't understand. Others understand. I said, I think like that. Because I have 34 in my class, or 35, but only 2 respond. I don't know the others. So rem t is actually t times ut. So first let me draw this graph first. Okay, we have, this is A, this is B. Okay, so now we draw graph A first. Graph A. Graph A is actually, let's say, AT, okay? Let's say this one is AT, this one is BT, for example, okay? So graph AT is actually only T, okay? Just like you have Y equals to MX plus C, okay? This C is 0, and XU here is in terms of T. This why equals to T, okay? And you take positive gradient of 1, so you have T, and then here is A, okay? Here is A, so you just put here is A, okay? Depends on what you use. You can use A, Y, whatever. Then you create the straight line, just like you learn in your school, Y equals to MX plus C. But this one is Y equals to, but this one is A equals to T. So gradient of 1 and T, okay? So here means you have value, you have Y intersection 0, okay? Add 0 here. And then you have gradient of 1. Then your X here is in terms of your T, okay? Then the next we go for the graph of B, okay? The graph of B, we try to, okay, let's say I'm trying to draw it in the same graph to make you understand. The next is the unit step function, okay? Unit step function is not here, okay? This is unit step function ut, which is bt, okay? I can just use bt. Don't confuse, okay? I just use bt, ut is the same. So bt is unit step function here, okay? If you guys can see, here is 0. Am I correct? Here is 0. So what, everything multiply with 0 equals to what? Everything multiply with 0, what will be, what is the value? Okay, everything multiplied by 0, you get 0. So the new graph here for this region, okay, for this region will be 0. Okay, will be 0. And then after that, you have the ramp, you have T, you have this red multiplied by the green. Okay, everything uh, multiply with 1 will become the number itself, right? 3 3 times 1, 3, 4 times 1, 4. So here, multiply with this, 1 multiply with the green, multiply with the red, you have this. Okay, means the same value. Okay, the same value, because everything times 1 become this number back. So this is your ramp function. This is your ramp function. Okay, so this is ramp function. It is a product of the t times by unit step function. Okay, okay, so this is it. Okay, I hope you guys understand. If you don't understand, okay, you guys can listen again to this recorded live lecture. Okay, and of course you can ask me again later. Okay, but I think now is a bit understand now because I already showed like this. Okay, I hope understand. Okay, you guys understand or not? If you guys not understand, you guys can replay the recorded live lecture. Okay, but thank you for saying not understand. Okay, means you are you are in the class. Okay, that is more important. Okay, uh, okay, this is what. Okay, this is triangular function. Triangular function. Okay, triangular function has a unit value. Okay, sorry, I got some messages now. Okay, here's triangular function. If you see the word triangular means it is in triangle. Okay, logic. Then you have this shape. Okay, the width is 2. Okay, the width is 2. Okay, please make a different, right? Units different. Like rectangular, the width is 1, but triangular, the width is 2. You see here? Okay, it's 2, right? 1, -1, 1. Because it's triangle, so you should have the, okay, not really. So this one is not really equilateral angle, not equilateral triangle. Okay, so make sure you see here, the width is 2, and then here, okay, this one is hypotenuse, okay. So this is the function, try t, for t greater than 1, regardless of the value, only we take the magnitude, it will be 0. Okay, so greater than 1 or less than 1, it will be 0. Then you have 1 minus negative t here. Then 1 minus negative t, you have some value, but I'm not sure you guys understand or not. Do you guys understand this graph? You guys understand or not? Do you guys understand? Or you guys understand, or you want me to explain? For me, I understand. You guys understand or not? All of you understand or don't understand? How to get this graph from the top function just now? This one. This one. You just need to open the modulus. So you will have later on 1 minus t, and then you have 1 minus t. Okay, then you later on, when you do y equals to mx plus c, you will have two straight line. Okay, you have two straight line here. Okay, that's why it's formed the triangle. Okay, it's formed the triangle. So remember, this is modulus, means always positive, but actually if you taking this one out, you actually have this 1 minus t and 1 minus t. Okay, I hope you guys understand. If you guys don't understand, let me know. Okay, if you guys don't understand, during when I share this lecture slide later on, okay, you guys just respond for forum. I don't understand this, I don't understand that. Okay, use the forum. Okay, next, sync function. Sync function is obtained from the Fourier transform of the unit rectangular function, okay, defined by this. Okay, sync actually we have sync t plus t. I think this one is very direct. This one is very direct because this one is sin t minus over t. Let's say you have sin pi over pi. I think this one is very direct, nothing special about it. I mean, nothing tricky. Okay, let's say the original. Okay, where's the lecture slide just now? Hilang. Oh, never mind. Okay. Okay. So let's say you have your scene, right? Scene graph, sine. Then sine pi, for example, pi over pi. Okay. So this is how is it you obtain the sine t function. Okay, sine t function is okay like this. Then you have, let's say you have another sine 3 over 2 pi, then 3 over 2 pi. So you get you solve for the value. Okay, then you will have this kind of graph. which is your sine function, your sin function, which is this. Okay, you can try this at home. Okay, please try this at home. You kira, you calculate pi, you calculate this, you calculate that, then you get the sin function. Okay. Not sure if I want to ask you to submit. I think no need. Okay, no need. Okay, but please try this at home. Okay, please try this at home for your own good. Okay. Then we go to, what is this? This one already. Okay, now we go to type of system. Okay, type of system is a system can be classified depends on how the system interact with an input signals. Okay, several classification. We have a linear system, we have time invariant system, we have memory and memoryless system, we have causal system. Okay, so linear. Okay, linear is what you guys understand. Maybe you already learned from your secondary school also. Linear is that if anything changes there in the input, it will be shown directly also at the outputs. Okay, so if you see here, x1t, okay, additive properties for additive, x1t equals to y, xt will resulted into y1t. Okay, input of x1t will produce output of y1t. And then an input of x2 will produce an output of y2t. When Okay, so we have then scaling homogeneities properties. Okay, sorry, where was I? Sorry. So x1t plus x2t will resulted in an output of y1t and y2t. This is what we means by linear. Okay, no tricky there. You tambah a, you dapat, you dekat output you akan ada effect of tambah a. Okay, kalau you tambah b, your output akan ada hasil of the tambah b. Macam tu. That is the direct. So no tricky part there. And scaling and homogeneity properties. So let's say you have time with a constant, okay, the output will also experience with a multiplication with a constant. Okay. These properties can be combined to yield superposition. So, okay, superposition x11t. Okay, then you have this superposition. A system is linear if it satisfies the principle of superposition. So please bear this in mind. Okay, principle of superposition is satisfied. I mean, if this is satisfied, you're going to have a linear system. Okay. Next, what is this? Next is time invariant system. Okay, also called fixed system. Okay, a time shift in the input signal results in the identical shift. Okay, in the identical shift in the output signal. So xt equals to y1t. Okay, I mean xt is the input and output is yt, for example. Okay, if we have a time shift in the input, let's say here, okay, this one is delayed. So the output will be delayed also by T naught. And how about YTXT system? Okay, this one. This one, okay. Okay, I want this one to be answered in the forum later on, okay? Okay. I want you guys to put your answer first, okay? Is this time invariant system or is it not time invariant? And what is your justification, okay? Try first, okay? Try first, then I will explain in the next lecture. Because if I'm do the talking, a bit boring, all the time I'm do the talking, okay? So this is the first task, okay? In the lecture later on, in the lecture slide later on, in the forum, okay? Please provide the answer here, okay? How about Y1TX system in the forum, okay? Is it time invariant system or is it time variant system, and what is it, okay? This one. Try first, no worry. You get it wrong, no worry also. We learn from mistake, okay? This one is, what is this? Memory and memoryless system, okay? So if the output at T naught depend on the input at the time T naught, regardless the input before or after. Okay, this is a bit confusing and you can read on your own. Okay, memoryless is that Hmm. Memoryless is that it doesn't depends on any value before or after the time. Okay, before or after the time. For example, this one is you guys can I just want to explain, okay, what you guys can see, read this on your own. Okay, example like VT equals to RIT. R is what? Okay, R is what? R is resistant, yes. So R is resistant. If you know resistance is a fixed value, right? Here in this graph, in this example, R is a fixed value. You can have the varying resistance, but R here means it is a fixed constant. So regardless of time, resistance is always, let's say V equals to 10 IIT. So your resistance is always 10. So this one is memoryless system. Okay, it doesn't depend on the value inputs before or after the time. Memory, now we go to the next, okay? Yes, it's correct. That's a resistance. Now you will go to the memory. Output at time t0 depends on input at time t naught and also input before and after. Okay. So for this system is that the output very much depend on the input, okay? With input before and after t naught, okay? Before and after t naught. It's a bit confusing here, okay? But I think you guys understand, okay? As it is influenced by the output is influenced by the input before and after the time, okay? Example, circuit with a inductor and capacitor is said to be dynamic system because the output depends on the past history of the inputs, okay? So what is the function of the capacitor, okay? What is the function of the capacitor, guys? What is the function of capacitor? If you guys can answer me. What is the function of capacitor? Keep on answer. I want to see the answer. What is the function of capacitor? Okay. Keep on answering, okay? Because if you're wrong, it's good. At least you know the right answer, okay? So capacitor and inductor, okay? Capacitor and inductor, both of them store energy, okay? Store energy, but in different form. But in different form, okay? Capacitor store energy in electrical charge, okay? And then inductor store energy as well, but inductor, if you see, it's like magnetic, right? It's stored in the magnetic field, okay? Store energy in the magnetic field, okay? Because if you see, inductor is like a coil, okay? What is this? Okay. Oh, next is causal system. Output at any time depends on the input only for t less than t naught, okay, and does not depend on the value of input for t greater than t naught. Okay, this is a causal system. Output only exists after an input was applied to the system. Okay, in the causal system, you require an input to be applied to the system. Okay, like okay, and output at any times depend on the input value for t less than t naught and does not depend on value of input for t greater than t naught. Okay, so here, okay, I think it's example is a bit easier. Okay, example, if you see here, yt equals to xt minus 2, okay, minus 2. So if, let's say, I teach you guys just now, we have this is actually time delayed. Okay, time delayed. Okay, time delayed after. Okay, after 2 seconds. After 2 seconds, you're going to have the value. Okay, after 2 seconds, you have going to have the some value. Okay, this is the causal system. This one is applied. After apply. Okay, this one is the output. Your output will be shown after 2. Okay, after 2 seconds. Okay, after 2 seconds, mean there is some input applied before. Okay, some input applied before. Okay, this one is non-causal. Okay, if you see, this is before. This output you already have before in future. I mean, you advance. Okay, so this one is non-causal, because causal is you have to have some things. Okay, you have to have something, only then you have the outputs like this. Okay, you only have the outputs after delayed by 2 seconds because you need some input before that. Okay, you need some input before that. Okay, so this is causal and this is non-causal. You see, non-causal is the output happened before, even before the time. Okay, means this is advanced, you already have the outputs. Okay, so this is non-causal. Okay, this one I intend to maybe we don't have time to cover this in class. Okay, let's see. Let's see where I can go this. Oh, tutorial. Okay, we will have tutorial, right? Okay, this will be tutorial. No worry. Okay, this will be tutorial. Don't worry. Okay, this will be tutorial tomorrow, and I will give some question later on. I will give some question later on for you to bring back home to do on your own. But we have some in-class exercise. Please bring calculator whatsoever, okay? And please bring some blank paper tomorrow, because maybe I will require you to do some answer, and you will upload at Padlet, okay? To show your drawings. All of you. I want all of you to do some, to participate, because I want all of you to understand, okay? So bring blank paper, because later on you will need to snap photo and then you need to upload at your Padlet. Okay, you need to upload at your Padlet. And then because if you remember we're going to have quiz next week. Okay, we're going to have next week quiz. Quiz will be, we have finished our lecture, okay? We're going to have quiz, 5 questions. Uh, and I will use e-learning. Okay, I will use e-learning. So if any of you are not inside my e-learning yet, please let me know, because don't let me know after the class, because if I mean don't let me know only after, very late last minute or after the quiz, because if you have inform me that you have e-learning problem. I mean you cannot access e-learning, mean you are not added to e-learning. Uh, Only after the quiz or whatsoever, then you will have different time. You have different type of question, from your friend, and I will make sure your question is different, and maybe it's difficult because it's manual. Okay, because in e-learning you still have option there. Okay, so I think e-learning later on, I will, one question 1 mark, but maybe I don't do the question yet. Maybe they all the question, maybe one is totally wrong, one if you answer 100% you get 1 mark. uh, if you take option C, maybe 0.5. If you take option D, 0.75. But one question will bring, I mean, one question maximum 1 mark. Okay. So I think this is good where I start to use e-learning as quiz. Last semester I didn't use it. This is good for, student with very high number, because now I have 2 section, one section 34, combine 70. It's a lot, it's a lot. Later on you will understand when you are a lecturer. Marking is a bit difficult. So that's why we try to have balance, some section have very little students. So the load is not even, distribute. So maybe you guys don't understand now. Okay. Let's say you have one question final. Let's say final you have, no, let's say test you have 2 question, ABC, ABC. So you have 6. Okay, one ABC, two ABC, you have 6. So 6 times 70 student, 6 times 70 student, you will have 420 answer to be marked. Am I correct? 6 times 70. Okay, because section 3 and 4, you have 420 exam to be to be marked. Okay, but at the same time, the other section, very low students, have less, so they have much lower, many question, I mean need to mark is much lower. But we have the same due date, we have the same due date to report the results of the test, and also to give student the time. So later on, if my section a bit delay from the section 1 and 2, you must understand me, because section 1 and 2 they only have 20 and 20 something student. But my section 1 34, the other section 34, means I have 420 different answer have to be marked for test. It's for me it's okay, but of course I'm human, if I have more students I will have more delay. So you cannot compare later on, why section 1 2 already get answer. You know why? Because you guys run away from that section 1 or 2. I don't know who ran away, but I don't know the one that initially in this class. I know them. Okay, the one that just flooding in, that is not initially in this class. Okay, I know you. The one that flooding in didn't do the pre-registration. You guys do the registration only, and maybe I am a student also. Maybe you want to observe this lecture, you like it or not. That's why. Because if you do pre-registration, you don't know the lecturer. Something like that. Then one of the tactic is that you do registration, then you go to each section, or this lecture not good, this lecture not good, something like that. Okay. Then some student may use the reason clash. Oh, I have clash, but actually not clash, but you don't like the lecturer. Something like that. Okay. Something like that. I'm the student also, okay. I understand, but I noticed this really not a problem among the Malaysian and Indonesian students. Okay, but it's okay. Okay, our tutorial is on Thursday. Yes, sorry, Adi. On Thursday, I mistaken with section 4. Okay, with that, we finished lecture. Forgive me if any errors on my side. Okay, if any errors or whatsoever. We'll meet later on, and I will share the recorded lecture. Remember the task that I asked you guys, the question just now. Okay, the one question just now. Okay, so the class is dismissed. I will share the recorded lecture later on. Okay, thank you.
Thank you, Doctor.